Hello everyone, welcome back. Let me share the screen and start the second session of Octave. Okay, hope you remember the last class. I'll just give the quick review. In the last class, we have just discussed the basic operations and the basic commands in the Octave, and we have just started with some arithmetic operators, and we have seen some relational operators. We were comparing this. Okay, further we'll move ahead. Okay, hope you remember all these things. So I will just clear all means all the variables which are there in the current workspace. It will be clear, and I want to clear the screen. So the screen is clear. At the same time, I just want to clear the history also. See that here, if you can see that earlier, you can see some commands. Now everything is deleted. Okay, so now what I'll do, we'll start with our some basic operators. Okay, in the last class when we were discussing the operators, I think I forgot to discuss the exponent operator. Means what? Here, let me just start the paint. Okay, so here the paint, fine. Let me just this. Okay, so here exponent is, suppose if I am writing 5 to the power of 5. So here this is what 5 into 5 into 5 into 5 into 5. So this is called the exponent here. And here we use the symbol like this. Okay, so here I will just go and show you from here. Suppose if I am writing 5 cap 2, it will give you 5 into 5, it will be 25. At the same time, if I am writing 5 cap 3, it will give 25. And we have a function to find out the square root is QRT. It must work so that here, okay, what happened? Let me just check this. What happened? Square root, fine. SQRT of 9. So it will give me the square root of 9, that is 3. Same way SQRT square root of 5 or its square root of 25, it will give me 5. Okay, so these are some basic operation and the functions we can perform. Okay, and when you are performing, suppose here, if you are not here, I just want to show you that here, suppose this is 12 divided by 6 plus 2. Okay, or 6 into 2. See that what the result you are getting here? You are getting result as 4. And the same equation, if I am putting this in the brackets here, you will get something as 1. What is the difference over here? Here, if you see, when I'm using this brackets over here, first this operation will perform, then the division will perform. It will follow the Bodmer's rule. So when you are writing some equation over here, you need to be careful that these brackets first you have to multiply, then if you're going for the division. Whereas here what is happening? First 12 is divided by 6, which you are getting 2, then it is multiplied with 2, you are getting answer as 4. Whereas here what is happening? First it is multiplying 6 into 2 times, the answer you are getting is 12. 12 divided by 12, that is 1. So these are some basic operation. You can perform any operation. Okay, like if you want to find the quadratic equation, you can write the simple way and you will get the answer directly. Okay, so now we'll move for the vectors. Okay, our next topic is vectors. Let me just delete this, and our topic is vectors. Okay, so here our topic, we are going to discuss vectors. Okay, vectors are nothing but it is basically a list, and the list can be horizontal list or it can be vertical list. Horizontal list means what? Suppose if I am writing 10 to 3, this is horizontal. If I am writing 10 to 3, this is a row vector and this is column vector. The vector which is in the column form, the vector which is in the row form, and you can have the combination of this. Suppose the 4, 5, 6, 7, 8, 9, and this is what a vector for here 3 rows and 3 columns. Okay, now we'll see that how we can work with the vectors. In for the vectors, again we will discuss this in detail in our fourth or fifth tutorial, where we'll see that vectors have the magnitude and the distance, all these things. Right now we are considering vector as a list, and to declare the list we have to follow certain syntaxes. Here how we can declare the list? Fine. Then you can ask that what is the use of list? Suppose I want to use 3 different variables, that is a equal to 10, this is 1, b equal to 20, c equal to 30. These are 3 different variables I have. Instead of that, I will just create a vector, and in this I will write here all these 3 variables at the same namespace. With this, what will happen? If you are declaring the variables at the same namespace, it will make the processor work easy to search the variable. Whereas if you see that here, if you have 3 different variables A, B, and C, that will allocate the memory somewhere wherever they get the place. Okay, but here when you are taking the vector, it will form on, it will save the memory in the continuous memory location. So here if you write 1, okay, you see this is 10, and immediate when the 10 finishes, 20 gets start. Means what? Here it will allocate the memory in this way. Like here if I am writing VC, okay, so here this is the first place, second, so here it will be 10, here it will be 20, here it will be 30. So always it will allocate the memory in the continuous memory location. So when the processor read this first variable, it will be easy for the processor to read the second variable, after the second variable, third variable. But it will take the same memory space as the 3 individual variables. Okay, so now here we'll see what are the different ways to create the vector. What happened? Okay, I just want to delete this. Fine. See here, when I'm creating the vector VC equal to 10, 20, 30. So what happened that here we got 3 values at the 3 space. So this will be at the first position. The index position is 1. This will be index position 2. This will be at the index position 3. So here, you see, I'll just create that now. Clear that. VC. We have 10, 20, and 30. If I want to display the value of the second index, then here if I am writing VC of 2, you will get this as 20. If I write VC of 3, so you'll get 30. Now if I try to display VC of 5, it will give me an error, out of bound, because the limit is of 3 variables only. Suppose I want to replace the value of first variable for index 1. So here I'll just write index 1 equal to 50. Sorry, here 50. So now you can see that 50, 20, 30. Now in the same way, if I try to assign the value at the 7th position, index is equal to 70. What will happen? It will not give you any error, but here it will be 50, 20, 30, 0, 0, 0, then 70. So what it will do, it will take the 7th position as 70, and whatever the elements between this, whatever the places are there, like VC of 4, VC of 5, and VC of 6, it will be filled by 0. So this is the way to just declare a horizontal row. here, when you are declaring the row, horizontal row or horizontal vector, here, if I am writing 10, 20, 30, if you're giving comma or not, it will not make any difference. It will create the row vector. Okay, so and in the similar way, if you want to create the column vector, suppose here we see 1 equal to 10. If I put semicolon here, okay, so that here you see it will be created in the form of column. So whenever you are putting this semicolon means here you are creating, this is one row, this is second row, and this is third row. Suppose if I want to create the 2-dimension or 3-dimension, suppose here 2-dimension. So here I'll write 1, 2, 3. Then I'll separate this with 4, 5, 6, then 7, 8, 9. So here, so that here you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 3 rows and 3 columns. Okay. Right now we will be working only with the horizontal vector, horizontal row, that is a vector, horizontal vector only. So let me just show you more ways to create this. Okay, let me just clear this now. Okay, what do you create that here? Suppose if you want to create a row vector from the elements 1 to 10. So you will just write this like this. This will be 1 to 10. In the similar way, if you want to create for the 100 elements, 1 to 100, you can see. Okay, then in the similar way, suppose if you want to create 1 to 100 with the interval like first value 1, then the second value, suppose 10, you are going to add each time 10. So here I will just put this. Now you see what happened. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So try to understand this. I'll just show you here. When I write this equation, VC equal to 1, this element is what from 1 to 100, and here I will give the interval, so that here if I am writing interval or steps whatever you take, here if I am writing 10, so after this 1 it will add 10. So I took here 0, so after 0 it will add 10. So first number will be 0, second will be 10, then again for 10 it will add more 10, 20, more 10, 30, more 10, 40, 50, 60, 70, then 80, then 90, then last is what? 100. Suppose here if I make it 20, suppose here if I am writing the statement like 0 starting till 100, and here I am writing 20. So it will be 0, second element will be 20, third element will be 40, fourth element will be 60, then 80, then 100. Okay, let me just show you here. If I am writing and here I am putting this 20. So that 20, 40, 60, 80, 100. Suppose if you want to write the multiples of 3 between what I can say 3 to 15. So here I will write multiples of 3 between 3 to 15. 3 to 15. These are the multiples. Okay, so in that you will give the interval of 3. So first 3, second one will be 6, then 9, then 12, then 15. Like this, we can create the vector. Whatever the values you want, you can just write this and you can create it. So that I hope you have understood that. Here, this is the way to create the vectors. Okay, so this is the basic introduction of the vectors. Again, the vectors we'll discuss in details. Okay, right now, what we'll do, we'll move to the topic of plotting. Okay, so let me just here and explain you the plotting. Okay. See, when I'm discussing about the plotting, usually why do we use plots? Okay, in the sense to create the graphs. Like here, if I want to represent some data, okay, then here drawing is not correct. So suppose here 1, 2, 3, 4, 5. Okay, then here 1, 2, then 3, then 4. And I want to just draw a graph like here. What is the position? This is always we take as x-axis and y-axis. Okay, so here this point, this combination here I want to. So then here at this position, then here at this position, and here I want to plot it. So here, this point is the combination of what? Always x and y. This is also x and y. This is also x and y. This is also x and y. Now, what is the value of x? Here it is 2. And here, what is the value of y? 1. What is the value of x here? 3. What is the value of y? 3. What is the value of x here? 4. What is the value of y? 2. Here, what is the value of x? It is 5 and it is 4. So when you are plotting something, always you will plot what with respective to the x-axis and y-axis. So you required what? X and y, two values. So your plot is like this. Here it is coming, then, sorry, it's going like this. So in Octave, we have a function called plot. Now, see here, if I want to plot here, I need x and y value. X, suppose 2 and 1, I am giving 2 and 1. Only I am writing 2 and 1. So what will happen with this? Suppose here I just, now you see that here the plot is there, and if you see the combination, you can see the dot over here. This dot we can replace with something else also. Like here we have some properties. Suppose instead of that dot, I want to represent with the circle. Okay, now you see that here. This is what x position is what 2 and y position is what 1. If you want to put the grids, you can put the grid and you can see that here 2 and 1. And if you want to put the grid from here, you can put it here from here. If you just type that grid, now you can see that here the grids there. And if you just put again grid off, grid on also you can use it. So that here. Fine. Now, what will happen that here we are representing only one point, but what we need the combination of different points. Like here, we need 1 point, 2 point, 3, 4 points. So what I can do for this, what we'll do for this here, okay, plot. What are the x values we have? 2, 3, 4, 5. So I'll write here vector 2, 3, 4, and 5, comma. Then y. What are the y values we have? 1, 3, 2, 4. 1, 3, 2, 4. Then here, okay. Now you see here, this. Then here you can see the plot. See that here. First point 2, 1. So this is the 2, 1. Then what is second? 3, 3. So here it is 3, 3. Then here 4, 2. So here you can see that x is 4 and it is 2. And here 5, 4. So x is 5 and it is 4. If you just go through this grid. Now, if you want here, suppose I want to play with the circle. I want to repeat. These are the properties that which this is marker. So here I can just see this. Okay, see that here all the points 1, 2, 3, 4, all these points. 1, 2. This is representing by the circle if I want. Okay, so if I don't want this circle to be there, so here I can just simply. So usually what we do, we take the x values. Suppose x is what here? What are the values of x here? 2, 3, 4, and 5. Then I'll take the y value, y equal to here 1, 3, 2, and 4. Okay, see what will happen. I'll get an error because x I'll redefine again here 2, 3, 4, and 5. Okay, now I'll just simply write x and y so that here I'll get a plot like this. Okay, now here if I want to give the title over here, so here right now we are in the plot, so I can just use title equal to here simple graph. Okay, this is executed. Now you can see that here it is simple graph. Then if you want to put the what I can say that label for x, so here x, I hope this will work, x label. So here x axis represents something something whatever you want to, right? Then at the same time here y label, here y axis represents something. Okay, now you can see that here whatever you write it is showing. Hope you understand the plot. So we'll do one practical, we'll create one practical graph. Then we'll see some more examples. Suppose here, okay, let me, okay, here at the same time it's working here. I will, so what happened? Okay, so here, what I'll do, uh, population graph of pairing for last 5 years. Simple. And so here, let me just check whether it gives the graph. Will not take from 50. We'll just go for 10 years. If they show us the graph, that will be better. Fine. Okay. Anyhow, we got it here. So what we'll do, we'll write for the 10 years. That is from 12 to 2012 to 22. Okay. So for that here, x-axis, which is starting from 2012 to 2022. 12, 13, 14, like this, it will create the. Then y-axis, y equal to, here I will enter the population. First 2012, it was the population here. See, I'm just putting whatever I'm getting from the, okay, so here. Then okay, I'm not putting the commas, it will be, it'll take as a two separate columns if I'm just putting the comma. So I'm just removing this here. Okay. Then Here's 1, 2, 3, 4, 5, 6. This is 7. 8. Okay, finally we have opened all the things. Fine. So now we got X and Y. So what I'll do, I'll just plot X comma Y. So now you can see that here, if I just put it that. So it has started from here and all these points. So fine. And if you just want to put that, what is x-axis years and what is y-axis here, I can just put label population, sorry, population of Bahrain over last 10 years. Okay, then what happened? Is it this one? Sorry, title it must be. Okay, then X label. Yeah. What is X label? Years. Okay. Then similarly, Y label. Yeah. Population. Okay. Now you can see that here, population of Bahrain over last 10 years, and here the years is given and the population is given. So this is the way we just create the graph using the plot function. Okay. And you may have some problems like, suppose one of the problem I'll just show you here. Okay, this. Suppose X value is given, which is from -10 to +10, and with the step of 0.1, and Y value is given for sine x. Sine usually is a graph will form in this way, like sine wave. Okay, so for creating any plot, any graph, okay, using the plot, you need x value and y value. So what we're going to do here, we'll create a vector with the x value, and already we have the y, then we'll create the plot. Okay, so here I'll just clear the screen. Then x equal to what is given, suppose here -10 to +10 with the step of 0.1. Okay, then at the same time y is given as sine of x. Then here I'll just plot x comma y. You can see that here it just created a plot x comma y. And if I want to create one more plot in the same window, then here we can use hold on, or it should be space. Hold on, fine. So that now, next, whatever the plot I draw, that same plot you can see on the same window. Suppose here I am drawing plot, okay, here, whatever the value is given, here -1, so -5, 0. So here I'll just take -5 first term, second term 0. Okay, then third I'll take 7.5. 7.5. These are the x value. Then what are the y value I'll take here so that we can see. First is minus 0.5. So here, okay, minus 0.5. Then second value I'll take here 0. Third I will take here 1. Okay. So here I'll show. So now if you see that this is the second graph which is at the position like here -5 and -0.5. Then second position here 0 and this. So if you want to put as many as the graphs, you can put by just putting that hold on, so that all the graphs, whatever you are going to draw using the plot, it will be drawn on the same window. Okay, hope the concept of the plots are clear. Okay, so now that's all for this video. In the next video, we'll see the control structures, which will be like decision making statement. There will be discussing if and if else, all the possible ways of that. If you have any question, please drop in the message. I'll get back to you at the earliest. Thank you very much. Let me